for number, what did I just say? 11, thank you. Sorry, my numbers are off. All right, so number 11 is about this comet, right? Okay, and you're given, really the only information you're given is sort of how long it took between two successive observations of the comet. What's that really giving you guys? What would that give you?
Period.
The period, right? Okay, so we know the period, and we know the eccentricity of its orbit, right? And it wants to know the semi-major axis of the orbit, okay? So here is the deal. The problem tells us that the astronomers first saw it in the year 574, and then they see it again later in 1994. So the period should just be the difference between these two, which is, what, 1,420 years? Agreed? I did that really quickly in my head, so tell me if I'm wrong. I think that's right. Okay, so is everybody good with that? All right, now, the problem, yeah, I guess technically you could add a 12th of a year, but it's, it's less than 1%, right? So I'm not even going to worry about it. All right, the eccentricity of the orbit is 0.932? Why did I set this down? I don't know. 9932. Okay, and the problem wants to know what the semi-major axis is, right? So we're looking for A. Okay, so what other thing do we need to know? Oh, I see. No, I'm sorry. Yeah, so we're probably going to need C at some point to answer this, would be my guess, right? Okay. So, because really the only information that we're given is the period, we need to be thinking in terms of period, right? So one of the equations I gave you in the video was basically Kepler's second law. And Kepler's second law says that the period of an object is equal to, I always have to rederive it, so I don't have it memorized. Is the 4 pi squared on the top or on top?
Top.
Top? Okay, thank you. And then it's over GM? GM, and then there's an R cubed in here, right?
Is it inside?
It is inside. Or you can do this.
Oh, yeah. Okay, that's all right.
Okay, so do we agree with that? All right, so I think this is a thing, and again, I was talking about this with Jacob during the tutorial. I wish I'd done an example like this in the notes in retrospect. So I guess there are a couple of ways we could do this. I guess first of all this, which M is this? What mass are we talking about here?
The mass of the big thing that it rotates around.
Okay, the mass of the big thing that it rotates around. So we're talking about a comet that the Chinese astronomers saw. So what's the big thing that the comet is going around? The sun. Yeah, comets go around the sun. Okay? So if you didn't know that, that's a thing you should know. Comets orbit the sun, not the Earth. Okay? Cool. All right. So this M here actually represents the mass of the sun, right? And we don't know the mass of the sun. All right? So there are two ways you can go about this. All right? So option one is, I guess you could just look up the mass of the sun and solve it, but on the AP test, that's not an option, right? You're not going to be able to pull out your phone, right? So, do you guys agree that this is a constant, though?
Oh, yeah.
Okay? So any two objects that are orbiting the sun should have this same constant, right? Okay? So what that's basically telling us is for any two objects orbiting the sun, the period squared should be proportional to the radius cubed, right? Does that make sense? Okay? So the way Kepler actually wrote his first law, he didn't write it as this equation. Kepler said that if you have two objects orbiting the same body, then the period of object A divided by the period of object B squared is equal to the radius of object A divided by the radius of object B cubed, right? Does that make sense? All right, so one of our two objects here is going to be the comet. What would be a good choice for the other object? Well, the sun doesn't orbit the sun. The Earth orbits the sun, though, right? Follow? Make sense? So, I guess that still doesn't really help us because now I need to know the orbit radius for the Earth, don't I? Damn it. Ah, shoot. I really should have given you guys more information on this now. Damn it. I get a giant fail on this. All right, so yeah, it looks like in order to solve this, you have to either know the mass of the sun or the radius of the Earth's orbit. And there's no way to solve it without one of those two things, so I need to fix that problem. Sorry?
I looked up the mass of the sun.
1.99 times 10 to the 30th, is that right?
Yeah.
Why do I have that memorized? I don't know. Okay, so let me do this though, because I think that there's value in finishing this. So, do you guys know what 1 astronomical unit is, 1 AU? Have you guys ever heard that term before?
Yes.
It was on some test.
Okay, so here's the thing, okay? So 1 astronomical unit is defined as, go ahead again.
1 Earth distance away from the sun.
Yeah, it's the average Earth orbit radius, okay? So let's do this, let's cheat. Let's call object A, let's make object A the comet, and let's make object B the Earth. Cool? Okay, so then watch what happens. So then the period of the Earth, how long does it take the Earth to orbit the sun? 1 year. What's the radius for the Earth based on what we just said? 1 AU, right? By definition, right? Follow? Okay, so now we can solve this thing. So let's see. The period of the comet is 1420. Period of the Earth is 1. Year, the years cancel. Equals the radius of the comet, which is what I'm looking for, over the radius of the Earth, which is 1 AU cubed. Follow? Do you guys agree that we can solve that, right? All right, so if you do that, let's see, so 1420 squared, and then we got to take the cube root of that. So it gives you 126 AUs. Oops. Come on, thing. Does that make sense? All right, so what that's telling us is that the average orbit radius, i.e. the semi-major axis, is 126 AUs. So whatever the Earth's orbit radius is, the comet is 126 times bigger. Follow? All right, so I apologize for not having given you enough information on this. I need to go back and do that. And this is a very helpful trick.
Now we need C.
Sorry?
Now we need C.
Right. Well, so now that we've got A, you can do, equals.
Oh, you already had it. Yeah.
Cool. So then I think from there the rest kind of falls apart. Remember, your shortest distance is A minus C, and your biggest distance is A plus C. Cool? Patrick? I mean, the answer here is written in meters. Either one would be acceptable, I guess, So I'll make sure that I'm more careful about giving you the needed information. It's totally my bad.
Or like, let's say, well, the AP test would make you answer an answer, not 2 means, right?
If they wanted it, they would probably specify.
Okay. Okay.
Good?
Yeah.
All right. I apologize. That is totally on me. Sorry. So what number was that? That was number 11. So I got to fix that on the sheet. Radius, Earth, orbit. Okay. Any problems, you guys? Eventually, yes.
Okay, wait.
All right, 12, 18, was there a 19?
Oh, this isn't that far, yeah.
Oh, the FRQs, so I'm sorry. If you have not yet done the two FRQs that were attached to the end, do those for Monday. Okay? Good? Yeah, it wasn't clear, so I didn't check them today when I checked. All right, so let's do number 18. All right? Number 18 is actually a really good one, and next chapter we're going to get to periodic motion, and there's something really similar. So if you see the trick now, it'll be easier when we get to 18, when we get to the next chapter. All right? Okay, so so number 18.